This is section 9.71, Systems of Inequalities and Linear Programming, day 1. So we'll just take the systems of inequalities first, and tomorrow will be the linear programming, which is a poor name for what you're actually doing because it's not really programming. So here what we're going to do is, it might say something like graph this. It's an inequality, or it might even say a system of inequalities. And I just want to open up the possibility that although you won't see it here in this video and probably not even in the textbook, but there's no reason that any of these examples or these problems have to just stay straight lines. You could have parabolas and circles and all that. This is a generalized process I'm going to show you that will work on anything, not just lines, but also parabolas and cubic curves and whatever life or the SATs or college throws at you. And the reason it works so well is because it relies on your ability to graph an equation. So the first step is to just change the inequality. If you have to graph something like this, don't do it as an inequality, do it as an equation. We know how to graph equations, so let's go back to what we know. We'll change it from this hard thing to this easier thing. And I want to submit that, you could solve for y and do the slope and y-intercept and all that, but I would want to submit that maybe this is a little bit easier, especially because it has less to do with fractions. So if you see an equation like this, you could choose 0 and choose x to be 0 and calculate what y would be. So if x is 0, then you can see that y is 8. And here you could choose y to be 0 also and back calculate and figure out what x would have to be in the first place. And then these are two very easy points to graph, 0, 8, 3, 0. And you can see, if I just go down here, they get plotted and you can connect the dots with a line. Now the question is, should it be a solid line or a dotted line? And it should be here we say these are going to be represented with solid lines and these be with dotted lines. That's how we know that this is a boundary line, that this boundary line here represents the boundary is also included in the region. So 0, 8 is on the boundary. It separates all the solutions, all the linear the ordered pairs of x and y that actually do satisfy the inequality. And then if it's on the boundary, because I know it's solid, I'm indicating that it's also a solution. Like 0, 8 is on the boundary line between what works and what doesn't, what's a solution and what is not. And then it also works itself. The boundary line works as well in the original inequality, because 24 would be greater than or equal to 24. Now the real question is, although you see it shaded here, I didn't exactly tell you how to know which side to shade. This is a boundary line that separates the solutions from the non-solutions, but which ones are the solutions? How do you know to shade here on the right-hand side or here on the left-hand side? And the simplest way to do this is that will work in the most variety of situations would just be to take a test point. And the easiest test point out there is going to be 0, 0. So you just test 0, 0 and see if it works as a solution. Plug in 0 for x, plug in 0 for y, and you get 0 is greater than or equal to 24, which is false. So don't shade in 0, 0, or even the region of points near it, they're neighboring it. Don't shade it, shade in the other ones. If 0, 0 doesn't work, then neither are any of its neighbors going to work either. On the opposite side of the boundary line, they will all work, and none of these will. So that's how you get that. Again, to recap, graph the inequality as an equation, then making sure that you're drawing either a solid line or a dotted line to indicate the symbol, and then test the points, pick a test point to shade the region, like 0, 0. I'll do that again. Here, we've got 6x minus 2y. Now, I know you could just solve for y if you wanted to. I think I just want to show you another way to graph a line. Choose x to be 0, and then calculate what y would have to be. That'd be negative 6. Choose 0 to be y, back calculate to get x equals 2. And you got these 2 points which you can connect the dots right here. I'm going to graph it with a dotted line because of the symbol. This is a less than symbol, so therefore this is a boundary that is not included in the solutions. These are all going to be, we'll see that these are all going to be solutions, and we'll see that these are all not going to be solutions. And the boundary line itself, these are not solutions as well. Because, for example, if you were to plug in 2, 0, this would be 12. 12 is not less than 12. So 2, 0 itself is not a solution, although it is on the boundary. Test. Let's take a test point, 0, 0, comma 0. So choose this right here, and we see that if you choose 0, comma 0, you get, when x is 0 and y is 0, you get basically 0 is less than 12. And that's a true statement. So 0, comma 0 is a solution, and all of its neighbors are going to be solutions. And then, so therefore, you can shade in all of these and not shade in all of these. And that's your answer. This is how you represent a region of solutions. Now, if you are given a system of inequalities, then basically there's one more step. You do steps 1, 2, and 3 that I've set up here already for each of them individually, and then figure out which region gets shaded twice. So over here I got a table. Now I'm going to have a table, a green table and a purple table. I'm going to test 0, comma 0 in the green equation, in the green inequality, and in the purple inequality, and shade appropriately. So you can see, I won't go through all of it, but you can see I graphed the green, shaded this, because 0, 0 works. And then I graphed the purple dotted line here and shaded this. And then notice that it makes this X right here. And although the part above the X over here on the purple, that got shaded once. All of these points over here got shaded another time once also by the green inequality. But these points to the left of this X right here in this region got shaded twice. And that means they are solutions to both inequalities, this one and this one. It's not too hard, but it is kind of a long process, and it requires you to be methodical about things. You have to do this whole process twice and figure out which regions got shaded. Here's another inequality. Sometimes the book calls it a conjunction. When you combine two inequalities together, maybe it might be more conducive to split them apart and consider them individually. So x is less than negative 2 is less than x, and x is less than or equal to 5. You might say, Bergman, where's the y? How am I supposed to graph things if they're not y's? Well, these are both, if you change them to equations, like I told you to do, in here as step 1, graph the inequalities as equations, then it's a lot easier to see that you just need to draw a vertical line at negative 2 and a vertical line at 5, dotted and solid. You see, dotted and solid. Great. And then you can take test points. And you can take test points, or maybe if you're kind of savvy enough to see, oh, wait a minute, I'm looking for all the x values, all the points on the graph that have x values between negative 2 and 5. And so here it is. These are all of the points that have x values between negative 2 and 5. And I figured I might as well, at this point, tell you about the audio check. The Academy Award-winning film for Best Picture is The King's Speech. It was back in 2011, The King's Speech. Great film, lots of fun, especially even if you're not British. Even if you don't like the British, it's fine. It's still a great movie because it's got great characters overcoming great adversity, and just really well acted by the people, and just lots of fun. So check it out. 2011, The King's Speech. Boom. You've been audio checked. So there it is. Let's take a look at some word problems. And I wanted to do some word problems the way that I've seen SATs drop word problems on you. They use alternate vocabulary. They say things like no more than or no less than. And that's kind of not the most simplest way of the most helpful way to help you write an inequality. Let's check this out. I modified this to suit our needs. Since it's SCH, I'm going to do volleyball. I'm going to do outward bound. But these are taken from SAT questions that I've actually seen. So an outward bound truck needs to be filled with bags of food. You've got bags of food and bags of gear, like stoves, tents, and clothing and stuff. The truck can fill no more than 900 pounds of food and gear. A bag of food weighs 15.5 pounds, and a bag of gear weighs 10.2 pounds. There should be no greater than 3 times as many bags of food than bags of gear. Write a system of inequalities to represent the situation. So we're not even looking for a graph. We just want to write the system of inequalities. And that's actually how a couple of SAT questions that I've seen, they'll have like 4 different sets of inequalities. You have to pick the one that's written well. I still think in those kinds of things, even though there's no graphing, you should really write knowns and unknowns. It'll organize yourself really well. Now it says that, and there's even a total, what I used to call a total equation. This is a total inequality. Things have got to add up to quote, no more than 900 pounds. So anytime you're comparing things, there's basically 3 options that you need to consider. Is it less than, or is it equal to, or is it greater than? Or it could be some combination of them. Now, if it says no more than, that means it's not going to be more than, right? The total of food and gear is not going to be greater than 900. So it eliminates this. What I'm trying to say is that no more than is equivalent to saying less than or equal to for this reason. So not greater than is less than or equal to. And that's why the inequality here at the end is using less than or equal to. My unknowns are going to be F for a number of food bags, and then gear, a G for a number of gear bags. And so then, given the weights, we've got 15.5 F plus 10.2 G is not going to be any more than 900. It could be less than, it could be equal to, but it's not going to be more. That's the first inequality. Now the second one, sometimes it's super tricky to figure out, is it, where's the fact here? Oh yeah, there should be no greater than 3 times as many bags of food than bags of gear. So does that mean you multiply 3 times F or 3 times G? Super tricky the way they write it. Sometimes I like to just stop and think to myself, which one are they going to have more of? Are they going to have more food, more bags of food, or more bags of gear? And so when I read this, I see that they're going to have uh, more bags. They're going to have more food bags. So if you have and fewer gear bags, so you could take the number of gear bags and multiply it by 3 to maybe even equal the number of food bags. Again, they say no greater than, and so that no greater than, it's going to be the same symbol. We don't want this symbol, so we use less than or equal to. F is going to be less than or equal to 3 times G. Super tricky to write, especially because the wrong answer choices might have this flipped or this 3 over here with the 3F. You got to be really careful about how you set up things. Here, Maya plays SEH volleyball as well as club volleyball. I know a lot of you athletes out there play club and also play for us as a school. So I wrote an inequality, an SAT kind of like looking inequality based on based on volleyball. And so she wants to get in no less than 20 hours a week of practice time without driving more than 200 miles a week. So she's going to go to her volleyball practice at SEH and she's going to go to her club volleyball. And so we've got some details about this. When she goes to a 3-hour practice with a club team, because they practice for a long time, she'll drive 35 miles round trip. It's a hike. She has to really drive. Maybe you can relate. The club teams don't necessarily practice right next to school or right next to where you live. When she drives home from her 1-hour SEH practice, SEH doesn't practice, maybe practices less. And she lives kind of close to SEH, so that the mileage that she's driving is only 5 miles. Write a system of inequalities to describe Maya's volleyball situation. So the unknowns are, I'm going to choose the letters C and S. C represents the number of club practices per week, and then S is going to represent the number of SEH practices per week. She wants to make sure that her total time is greater than or equal to 20 hours, no less than 20 hours. She wants to put in the time and make sure she's getting better and better at volleyball. This is something she's prioritizing. So she wants less than 20 hours is not going to make her a champion. So she's going for she wants to make sure she gets no less than 20 hours a week. But she's trying not to kill her car. Total distance has got to be less than or equal to 200 miles. So there's going to be some balance. In order to satisfy both these conditions, she's got to put in enough practices that will not kill her car. So the way you can write this is 3 times C. She'll get here's a total time inequality. 3C plus S would be the total time she spends, and that cannot be any less than 20 hours per week. It can be greater than, it can be equal to, it can be greater than or equal to 20. And then the total distance, she's going to put 35 miles for every club practice and 5 miles for every SEH practice. So 35 times C plus 5S is going to be your total distance, and that should be less than or equal to, what do you think? If you've been tracking, you should be able to figure that out, I hope. That's going to be what you do. And so this would be a system of inequalities that would represent her situation. Now, if you wanted to graph these two, like you could put vertically, you could say that as like instead of y, you could say it's a c-axis, and instead of s, horizontally, you could put, instead of x, you could put s as the horizontal axis, and you could graph, and you could find a region of actual values that would satisfy this. But right now we're just looking to set up the inequalities from the word problem. So I want you to start in ING1, do the first problem, and I'll see you in class.
All right, everybody, I'm going to show you today how to graph inequalities on both Desmos and on the TI Inspire. Desmos, if you want to graph an inequality, one helpful thing to have open is the keyboard. You click that, show the keyboard thing, and then you can see all these symbols right here that you might need. So for example, y is greater than or equal to x squared plus 2. You can see right there. And notice that if you change it to just greater than, then you get the dotted line also. Dots. Boom. So here on the Inspire, go to Menu and Graph Entry Edit. And if you try and do a function, what actually happens, it'll give you this f of 1x is equal to, and you might think, oh, what I need to do is delete the equal sign. So press delete, and all of a sudden it says, wait a minute, you don't really want to do a function. You probably want to do one of these. And so you have the option of doing relation or anything like this. So let's go to greater than. And you notice that it's actually no longer graphing a function. It's graphing a rel1, relation 1. So you can type in x squared plus 2. And then hit enter, and there's your graph. And you can see it's also dotted right there. Let's do another one just to see how they look. You can do how they overlap. Y is less than 4 minus x squared. It's really fun to look at the overlap and see if you're looking at these simultaneously at the same time, then the system, the point that satisfy the system of inequalities is right here. You can even plot that point like comma A, comma B. And note that here, these are all the points. Let's label it. These are all the points that satisfy both of these inequalities. Let's do the same thing over here. The Inspire. Go to Menu, Graph Entry Edit. I guess we want another relation, don't we? You can press the up arrow to get to the previous one. Rel 1, Rel 2. Rel 1, Rel 2, up and down to cycle through. All right, so then we've got y is less than. How do we type it less than? Oh, let's go to the menu. And you notice, sorry, not the menu, the library. This is the whole catalog of everything you could possibly want. Number 1 has every single function listed, and that's great, but actually what we really want is number 4. Tab 4 has all the symbols, and you can use the arrows, left, right, arrows, up, down to cycle through these catalog of different symbols. We want this symbol right here, less than symbol. I'm going to hit enter. Y is less than 4 minus x squared. Enter. Boom. There you can see there's the same region.